Now, accessing Linux file system. It's actually our chapter. And when we talk about accessing Linux file system, we all understand that it represents the root directories in Linux operating system. And this tells us a lot about how files are actually stored within again the Linux operating system. So when it comes to accessing Linux file system, I know there was a chapter which we talked about Linux file system, and we did actually introduce what is Linux file system, what makes up Linux file system. So in this particular chapter, it's all about enhancing whatever thing we did on Linux file system. So here we have around three chapters or three topics. The first one is to identify file systems and devices, that is identifying file systems and devices. And secondly is mounting and unmounting file systems. So we need also to understand what do we mean by mounting and unmounting. And then the last one is about locating files on the system. So how do we locate files and which commands can we be in a position to locate files? So we will start with the first one, identifying file systems and devices, and then we will move to the second one and then the third part. So this is not a broad unit. So we are using a unique operating system, and this one is based on Redhat Enterprise Linux 8 version. And we will have bits of practical or practicalities in it. But first of all, it's better we understand the terms that are related to file systems and devices, or which are these file systems and which ones are the devices. So the first part in this is we will talk about identifying file systems and devices, but we want to understand what do we mean by that. So we have the first part, which is all about storage management concepts. You see, it's all about storage when we talk about Linux file systems. So what are some of the available or what are some of the concepts, especially the storage management concepts that are used when it comes to identifying file systems and devices? So at this point, we will talk about storage. So if I can give, let's say, VI editor, we can talk about storage management concepts. So I'll try to explain. So when it comes to storage management concepts, we're talking about the files on a Linux server. You see, Linux operating system entails files. And when we talk about files, they are meant to be accessed by different users. So we have files already in the Linux operating systems. So these files on a Linux server or Linux operating systems are accessed through the file system hierarchy. The file system hierarchy, which is actually a single inverted tree of directories. So in the previous chapters, or the first chapter in Redhat Enterprise Linux 1, we were able to talk about the file system, and we talked about a file system which is related to an inverted tree. So it's like an hierarchy of an inverted tree. So this file system hierarchy is assembled from file systems provided by the storage devices available to your system. And each file system is a storage device that has been formatted to store files. So here it means that the Linux file system hierarchy presents a collection of file systems on separate storage devices, as if it were one set of files on one giant storage devices that you can navigate. So much of the time, you do not need to know which storage devices a particular file is on. You just need to know the directory that files is in. And sometimes, however, it can be important. You might need to determine how full a storage device is and what directories in the file system hierarchy are affected. Again, there might be errors in the logs from a storage device. And if you remember the logs from the previous session, we were able to talk about important information that can help us to troubleshoot our system. So at that point, you'll find that some errors may come up in the logs from a storage devices, and you need to know what file systems are at risk. You could just want to create a hard link between two files, and you need to know if they are on the same file system to determine if it is possible. So those are what? Just an overview of what storage management concepts are. So again, you need again to talk about the file systems and mount points, because as far as we're talking about the storage management concepts, we need also to talk about, storage management concepts in relation to the file systems and mount points, in relation to file systems and mount points. So these are two concepts, the file systems and the mount points. So when it comes to the file system at this point, you see, to make the contents of a file system available in the file system hierarchy, to make the contents of a file to be available, or the contents of a file system to be available in the file system hierarchy, it must be mounted to what? It must be mounted on an empty directory. So here we are talking about the contents of a file system. For it to be visible, we need to mount those contents into an empty what? Into an empty directory. And then this directory, now the empty directory itself is called what? It's called the mount point. The empty directory is called the mount point. So here we have what? Mount, which is actually a process. You can say like it's a process of what? You can say it's a process of writing, let's say writing contents of a Linux file system, process of writing contents of a Linux file system into an empty directory, So it means that if it is a directory, So if it's a directory, then it means now that the mount point itself is what? Is the name of the empty directory. Is the name of the empty directory. Is the name of the empty directory. So we have the process of writing contents of a Linux file system into an empty directory that is called the mount. And then we also have the name of the empty directory where the contents are mounted. It's actually referred to as the mount point. So once mounted, if you use ls to list that directory, you will see the contents of the mounted file system, and you can access and use those files normally. Many file systems are automatically mounted as part of the boot process. And again, if you have only worked with, let's say, for example, the Windows operating system drive letters, this is a fundamentally different concept. It is somewhat similar to the NTFS mounted folders features. Now, so that is about the file systems and the mount point. So at this point, you are in a position to define what the file systems is or are, and then what is a mount point and what is mount. Now, again, we also have like the difference between the file system, the storage, and the block devices. So we have, let's say, file system, we have storage, and what? And block devices. And block devices. And block devices. Now, you see, when we talk about the file system, we're talking about how the contents how the contents or the contents that needs to be written, or how data are stored in Linux operating system. So we have the file system itself, which is actually an inverted tree. But in this case, we have like a low level access. So we have like, if you want to achieve a low level access to storage devices in Linux, then we should be provided with what? We should be in a position to use something called block devices. So block devices is a low level access to storage devices in Linux operating system. And then when it comes to these block devices now must be formatted with a file system before they can be mounted. So we have the file system. So you see that for us to access the contents of a file system, we must use what? The block devices. And these block devices again must be formatted with a file system before they can be mounted. So block devices are stored in. So if you remember that we have like the Linux file system hierarchy, for example, we have home, let's say home, we have like dev, we have like, let's say bean, we have like root, we have like etc and so on. But we're talking about the block devices. So specifically, block devices are stored under this particular root directory, which is actually /dev. So /dev is a root directory where block devices are stored. And of course, any other related device files can also be attached to this particular directory, which is a /dev. So devices files or device files are created automatically by the operating system. And especially in Red Hat Enterprise Linux, we have, for example, the /dev, because we have different ways. For example, if you have, let's say you have a flash disk or USB. For USB, you'll find that it will be captured under /dev /sdb. So SDB is always a what? A removable disk. When we have, let's say, the hard disk, that is the Linux operating system hard disk, then it should be captured as /dev /sda. And then when you have, let's say, the CD /DVD, if you insert CD DVD, because it acts as a storage device, it should also be captured as dev_sro. So these are what? These are different ways on how Linux operating system can do what? Can read devices. So when you talk about block devices, this is actually like a low-level access to storage devices in Linux operating system. Now, another concept we need to also to understand when it comes to this, we have a concept called disk partition. We have a concept called disk partition. And when we talk about disk partitions, in Windows operating system, we usually talk about formatting. Format my system. But here, it's like creating a subsections of the entire disk. If I have a disk that is around 50 GB and I want to create subsections, I need to use, let's say, to do something called the partition. So disk partitions normally, you see, normally you do not make the entire storage device into one file system. So we can have different sections. We can have, let's say, for example, we have a block device. This block device has been formatted with one file system, but at most cases, it's not a requirement, or it's not a requirement that we make the entire disk just to have only one file system. We can have all subsections, different subsections to have different what? File system. Okay. So storage devices are typically divided up into smaller chunks called partitions. So chunks are what? Partition. What is partition? So here we're talking about the partition. Partition is a smaller subsections for an entire disk, or in other words, you can talk about storage devices are typically subdivided up into smaller chunks or small chunks called what? Called partitions. So in this case, we have the benefit or the importance of having what? The partition. And partitions allow you to compartmentalize a disk. The various partitions can be formatted with different file systems or used for different purposes. And for example, one partition can contain user home directories, while another can contain system data and logs. And if a user fills up the home directory partition with data, the system partition may still have space available. So if I can just show you by example what we mean or what we have here. Okay, so we can have it. So here, for example, if I want to check, let's say, different blocks, I can use a command lsblk, press enter, and you can see that I have these devices. Now, this is the shortest way. It's actually a command used to do to display the available blocks. Now, I know that I've actually showed you that for the hard disk, for the system hard disk, they are actually referred to as or given a notation /dev/SDA, but it actually differs. You see, for example, in Redhat 8, for this case, I have this particular device which is called what? It is called NVMe0N1. So I can have NVMe0N1. You see, this one is a what? This one is the hard disk or the system main disk. So when it is the system main disk, we have different partitions. So this is like the parent, and you can see the parent is the total size is actually 40G. That is the 40 GB, and it's a what? It's a disk. But now this 40 GB or 40 GB disk has been given a partition or has been subdivided into two partitions. We have this one, which is the first one, and we have this one, which is the second one. Each one has been assigned a what? Has been assigned size. The second one has 23.3 GB. The first one has 4.7 GB. So this is what? This is the parent disk, and this is actually what? The hard disk. Now, whenever you insert, let's say you try to insert anything on the CD-ROM, you realize that it will always be displayed or visible under SRO, which is still under what? Which is still under dev. Now, if I can see dev so that we can see whatever is happening, let me ls. You can see that we have all this under what? Under dev. We have all this under dev. And you can see that at this point, if we can look for, yes, we have this, which is NME0N1, which is the main or the parent hard disk. And then we have 1 and 2, which are what? Which are, they are the partitions that comes from the parent, that has come from the parent. So when it comes to, let's say you want to see specifically about NME0N1, let me clear the screen, you can just use ls-l, and then you can say dev nv, and then n, I think 01 something. Okay, so lsblk, let's see what is happening. It is actually this. So if I repeat, so NME0N1, let's see. Yeah, so you can see that is a what? We have here meaning block. This is the permission. Now this is the owner. And then of course we also have like this a disk. And you can see that we have what? Dev NVMe0N1. So here it means that we have what? That is the parent what? That is the parent hard disk. Now another part we need also to talk about is something called the logical volumes. When you talk about the logical volumes, Logical volume is another way of organizing disks and partitions with something called the logical volume management, or LVM. So that will be covered probably in the next chapter. And with LVM at this point, is actually one or more block devices can be aggregated into a storage pool called a volume group. So it's actually like grouping of what? Grouping of storage devices or grouping of block devices at this point. So when you group these block devices into a storage pool, this particular storage pool is called a volume group. And then the disk space in the volume group now is then parceled out to one or more what? Logical volumes, which are the functional equivalent for partition residing on a physical disk. So you need to understand that when you talk about what is a volume group, and secondly, what is a logical volumes? What is a logical volumes? So we are talking about LVM, which is another way of organizing disks and partitions. So it's not only attached to the partition or only attached to the disk partitions. It can also be taken back to something called the logical volumes. So again, the same thing. With the LVM or with logical volume management system, LVM also assign names to volume groups and logical volumes upon creation, and LVM creates a directory again in the /dev. So with that, this is actually something that is still ahead of us, and it's actually on Redhat 2, where you can do what? Where you can maximize on LVM, but still you can also read ahead by doing more research on logical volumes management, or LVM in short, and just see how disks are also organized and also partitioned. So LVM creates a directory in /dev that matches the group name and then creates a symbolic link within that new directory with the same name. So it is actually more similar to disk partitioning, and with this you'll find that the same way disk partitions assigned names to disk is actually the same way LVM can also assign names to disk or attach names to disks. Now, how do we examine? Because now we want to see how do we examine the Linux file systems. So examining the Linux file system, we have commands. And in Linux operating system, especially with Red Hat 8, we have a new command which is called what? Which is called df. So when you type df at this point and press enter, you can see that it tends to list what? It tends to list all the file system, both the block devices, disk partitions, and everything attached to disks, block devices, and all that. So at this point, we are looking at or using a command that shows or that helps us to get an overview of local and remote file system devices and the amount of free space available on it. So here you can see that we have the file systems, we have the blocks, that is, then we also have the used space, we have the available space, and then where it is mounted, So remember the concept of mounting. So df command is a command used to get an overview of local and remote file system devices and the amount of free space available there. So when the df command is run without arguments, it reports total disk space, used disk space. I mean, you see, for example, for a command or Linux command, it must have like 3 sections. One, it must have the command itself, then it also must have the argument, and then lastly, I mean, it must have the option and then the argument. So when the df command is just executed without an option, what does it show? It actually reports to us the total disk space available, the total disk space used, the free disk space and the percentage of the total disk space used on all mounted regular file systems. So it reports on both local and remote file systems. So at this point, you'll find that we can also attach some options. We can attach some options. So we can have like df-h. You can still get like, we have some display. You can use df-H. You can still that you're getting details. But in this case, like whatever thing you're getting, it's either clear to you, because if you compare only, let's say, the df alone, you see, I've actually used the df-H. At least I'm getting the size in terms of a GB. But when you use just the df alone, it will only give you the total size in terms of what kilobytes. So you have to sort them out to ensure that which command and plus which option are you using. Now, that is df. Df is the first one. So for you also to get more detailed information about space used by a certain directory tree, you have to use what? du. That is the disk usage. So you see now that we are trying to get or to read the file system by using what? du. So in this case, we can also attach some options or optionalities on this particular command. So how do we go about it? So if I use du-h and press enter, you can see that I'm actually getting probably some information. And do this information, is it like human readable or is not human readable? Now, I've actually used du with -h or lowercase. Now, what happens if I use du-H? So you still see that we are getting, or we are also arriving at the same one, at the same answer. Now, you see, using -h and using -h options basically help us to convert the output to human readable format. And the du command only shows the size of all files in the current directory tree recursively. So that is about what? That is about identifying file systems and devices. That is about what? Identifying file systems and devices. Now come to this part. What do we mean by mounting and unmounting file system? What do you mean by mounting and unmounting file system? So in this case, I'm not going to spend a lot of time here. It's just something, just a revision of what we already did. So let's say v part. So I'm just getting my own what? My own editor. So here we are talking about what? Mounting, let's say file system manually. So there are two ways on how we can mount what? The file system manually. Now, remember we started this topic by talking about the process of writing the contents, or the process of writing contents or making contents in file system is referred to as mount. But now the process, or because we are mounting it to, or making, or trying to write the contents of a file system into an empty directory. That empty directory is called a mount point. It's called a mount point. The process is mounting. Now, when it comes to mounting, we can actually mount in two ways. We can mount manually, and again, we can mount persistently, like permanently. So we can start with mounting the file systems manually. So when it comes to mounting file system manually, we can talk about a file system, because getting this concept, we must attach a file system to it. So a file system residing on a removable storage device needs to be mounted in order to access it. So anything written to a file system, you cannot be in a position to access it as a user unless it is mounted. Now, the mount command, the command is what? The command to be used is mount. This is the command. So this is the command to use. What does this command do? The mount command allows the root user to manually mount a file system. It helps a root user to manually mount a file system. The first argument of the mount command specifies the file system to mount. The second argument specifies the directory to use as the mount point in the file system hierarchy. So there are two common ways to specify the file system on a disk partition to the mount command. To the mount command. So there are two common ways to specify that. One, you have specified by def, that is the /def, and by specifying /def, you have to mention where the file is. Secondly, you have to give the UUID written to the file system, that is a universally unique identifier. So now you have to identify what? You have to identify the block device. So where do you want to do that? So I can just give you like how we do it. Let's say Q, just for quit. In this case, you have to switch as root. And then you are connected. So assume that I want to mount. Let's assume that I have, okay, let me go to CD. Okay, already we are actually at def. And if you list, let's say LSBLK, you can see that we have what? We have this, which is actually the second partition. Now I can go back to this, let's say MNT. Let me see whether we have some files. Let me create a directory called data. So if I pwd, if I ls, you can see that we have what? We have a folder called data. Let me just do it. We have a folder called what? Data. We have a folder called data. Now, what is the path or the absolute path for data? It is actually under MNT, under data. MNT data. /MNT /data. So if I want to mount now, and remember we have this particular file, dev /nvmen01, is it one? Yeah, 01 p2. So it means that we have this particular file, which is called what? nvmen01p2. We want to mount that to where? To data. It's like we are trying to rewrite. So how do you go about that? So you will just use the word mount and then /dev and then say nvme01p2. Where are you mounting to? /mmt and then data. You see. So this is the command, which is called what? The mount, which is basically used to mount. And the second one means what? So the first argument of the mount command specifies the file system to mount. Specify the file system to mount. And the second part, so the first one here, the first one means what? It specifies the file system to mount. And the second specifies the directory to use as the mount point in the file system hierarchy. So this is how you do what? This is how we mount. This is how we mount. So if you press enter, then everything is going to be okay. So this is how you can mount and how you are mounting it manually. You are mounting it manually. Now, if you want to use, let's see. So it will give me an error because it's actually a non-file system, but that is what? That is the way to go about. So you have to create the file and then ensure that you have the mount point. Secondly, we can also talk about mounting by file system, UUID. The first one was mounting by block device name. So mounting by block device name. So this is how we do it. like mount, that is the command, and then def, and then you can say nvm e n01 v2, and then /mnt/data. Now this is what? This is mounting by block name. Now let's see this. The second one is mounting by file system. File system, okay, file system UUID. And what do UUID stands for? What? UUID stands for, it actually stands for so here you can just have like universally unified identifier. So this is how we mean. So these are stands. So you can mount by block device. You can also mount by file system. So how do we do that? So if I want to mount by file system, we need to specify the file system. So if I can press enter just to show you how we can mount by UID. So we can say ls_blk just to show you what? To show you the UUID FP. So with this, you can now see that we have this. These are what? These are what is referred to as UUID. It's actually universally unified identifier. So how do I mount this? How do I mount? How do I mount this? So it's actually easy way because it's more similar to the other one. So you can just use the word mount and then you choose the UUID. So if it is this, you can just copy and then put it in double quotation, paste it. Let's see, paste it, and then put that, and then say /mnt/data. So you see, it's actually the same thing. Why? Because the first one was all about using the file name or the block device name, but we also have the UUID. So I can use both cases to mount my data. To mount that. So after mounting, you see, mounting means what? Ensuring that users can access the contents. But what happens if you have mounted, but you don't want again that to be available? You can just use what? You can just use umount. So umount is the opposite. Umount, and then say def, and then say mnt, and then data. You see? So initially it was mounted to this Now you are trying to make them invisible. So that is the reason why you are mounting. So when it comes to this, we do not actually have much when it comes to mounting and unmounting. So the last part, of course, to talk about is locating files on the file system, which is the simplest way also to do. Okay, so this is how do you locate files on the file system? So locating files on the file system, we are required to use two commands. One is the locate command. Locate command, and locate command what? That's what this one searches. Right. So okay, you can just use the same concept. Okay, let's say, okay, or file parts, let's say, and returns. instantly. That is the locate. But now find command does what? Yeah, so these are the differences between the two. So when locating files in the file system, we are required only to use two files. One, we're required to use the locate command, and again, we're required to use the find command. So if I can just show you by example, how can we do this? So assume that I want to locate, okay, CD, let me go to this directory. You know, etc is actually like a root directory. And if I ls, you can see that we have all these files. So if I want to locate a specific file such as passwd, how do I go about? I will just use the word locate and then say passwd, press enter. You can see that I am getting all information or any word that has what? Passwd, just by using what? Just by using this particular command, locate passwd. You can again say you want to locate, let's say, image. You see, I'm getting all what? All searches that any file that contains the word image or the name image, it will all be displayed. Now, if I want to perform, let's say, I want to perform locate case insensitive, locate -I, and then say, let's say messages. You see, I'm getting what? In upper cases. I'm getting anything related to messages in upper cases. That is by using what? By using locate -I, then messages. So that is how to use what? Locate. Now using what? Find. So if I want to find, let's say, a name, because find now locates files by performing a real-time search in the file system, right? I can do what? Find, then // I want you to find a name, which is sshd_config. So it's trying to do what? It's trying to find, you see, like permission denied. Find run USR just to allow some permissions. So there are concepts that if you want to do what? If you want to search, you will be either be restricted because you do not have what? You do not have enough permissions. So find again, if I can use etc, let's say -name, and then put that. I want anything that has what? Anything that has the word what? Pass. Anything that has what? The word pass, and then it does. You see? So here we are talking about any word that contains the word pass. So it's actually in the middle. So this what? It searches for files in the etc directory that contains the word pass. Anywhere in the names on host, that is how we do what? That is how we find them. So in this case, the two commands are basically used to locate the files. And that is all about locating files on the file system. So locating files on the file system, we use find and locate. Mounting and unmounting file system, we use mount command to mount. We use umount for unmounting. Then identify file systems and devices, that is it. Then come to the last, we have the summary here, that storage devices are represented by a special file type called block devices. And then the df command reports total disk space, use disk space and free disk space on all mounted regular file systems. And then the mount command allows the root user to manually mount a file system. And then all processes need to stop accessing the mount point in order to successfully unmount the device. And then the removable storage devices are mounted in the /run/media directory when using the graphical environment And then the find command performs a real-time search in the local file systems to find files based on search criteria. So that is all about accessing a Linux file system. And I think we can now meet in the next chapter. So